Hello and welcome back. So today, or for the next run of videos, I have procured this old Heathkit oscilloscope. Picked it up on eBay. Now, I'll give you a little background. Here in the shop, I usually buy an old oscilloscope. I don't need advanced functions on a scope. So I usually buy an old one, an old Hameg or Crotech or old Tektronix, for about 50, 60, 70 quid on eBay. They usually run fine. I run them, and when they die, I scavenge any parts and go and buy a new one. And so over the years, I've been through maybe 4 or 5 scopes, and they've all been solid state, and most of them, unfortunately, you can't get service data for them or anything like that. So when they die, they usually, unless you're set up for advanced repairs, there's not much really you can do. So I decided that this time I would get myself a valve oscilloscope. One, because they, even though the technology is older, in terms of serviceability, they are much better. So I know that if anything goes wrong with this scope, it will be easy for me to fix and get back up working again. So the idea was to buy a scope that I could carry on doing that. And I picked this one up on eBay for £25. And as well as the scope, I got the original build documentation for the scope. That's got things up here I can show you. It's got all the bits and pieces that I need, not only to help me restore this, but just to help me keep it working, which is great. Lots of diagrams that fold out with parts, lists, and all the things that I could need. Perfect. So I got that. It's got you teach how to use it, how to build all the other bits, and how to do the adjustments, etc, etc, etc. How to do phase measurements and what they mean. It's got everything in here, which is perfect. And actually, I'll show you what it says on the first page. It says the model OS-2 oscilloscope was designed as a small compact instrument for use by the electronic service engineer, laboratory technician, or by amateur radio enthusiast and hobbyists. A number of the useful facilities are incorporated, including push-bore horizontal and vertical amplifiers, automatic lock-in synchronization circuit, retrace blanking amplifier, provision for connection to vertical plates of the CRT. So actually it's quite a well-spec scope. Lots to do on it. Now, first thing I notice is that the plug's been cut. So, let's think about this. If the plug's been removed, it's for one of 2 reasons. First reason is that there's a problem with the scope and they didn't want it plugged in. And I would say that's 95% of the time. Or with any electrical product, actually. The other 5%, the second most likely option, is that somebody needed a plug. And this oscilloscope has probably been sat there for X amount of years. It was probably replaced by something and then just put to the side. Somebody needed a plug, take it off, done. So we need to investigate why that is. Actually, the cord itself is actually in quite good condition. So I'll either put a new plug on, or I'll put a whole new put a moulded plug and lead in. Also got the original connector leads with it, so I've got everything here that I need bar a plug. So to the side, and let's have a look. So we've got the display up here. What I will actually say is how small this scope is. Here's a ruler. It is. Let's turn it that way so we can see. 7.5 inches tall by 4.5 inches wide by just over 12 inches deep. So it's a small scope. I wonder if this was used almost like a portable one that a service engineer would carry around. Look at it compared to my hand. It's quite a small scope. I wonder if it was carried around by service engineers when they were servicing TVs and things in people's homes. Because it certainly doesn't weigh a lot at all. Very cool. So anyway, let's look at the front of this scope then. So we've got vertical input, horizontal input, and we've got a 1 volt peak to peak calibration port. So you go from here direct into there. You get a 1 volt peak to peak on the screen, and then you can do your settings. All the main controls that you need. On off light. The brilliance control also acts as an on off switch. It clicks into place, and then you can just turn that to where you need to. The rest of them all seem to turn okay. Some of them do feel a bit scratchy, so they'll need cleaning. But apart from that, it all looks good. Let's spin this around. Have a look at the back. So there's our power cable. You can see a bit of corrosion here. We've got an adjustable pot on the back. You can connect directly to the plates of the CRT. I think that's what they do. Oh, vertical input. There you go. So you could connect I guess an external source. I've already removed the two screws in the back, because to get this out, you unplug those and oops, wrong way. Once they're unscrewed, you can just pull it out. So you get the window, you can put your cable through there, and then you can pull it out and get the case out of the way. Let's have a quick look inside the case. You can see lots of dirt and grime. So we'll be cleaning that up. Oh, bits falling out, there you go. So we can put that down to one side and have a look at our scope. So, as you can see, we've got valves inside. Thumbs up for valves. Okay. Notice a lot of corrosion around the scope. It's certainly quite dirty. So here's the main CRT, and then here is the CRT socket. When I'm restoring this, I'm actually going to remove the CRT from the unit and put that away safe. Probably need to clean it up. What else have we got? Wonder if one of those caps have been replaced. Here's our mains power cable. Nice to see it's a 3-prong grounded one. Right, so this is what I'm interested in. We've got some valves. Now, let's make this exciting to watch, shall we? Now, for somebody that works with guitar amplifiers, there are some valves that I'm more interested than others. Okay, and we'll start with this one here, the EZ81 or EZ81. This is a full wave rectifier valve. I think the American equivalent is the 6X4. Not. I'll have to look that up, but let's get that out. And look, you can see it is branded Heathkit. Look at that, how cool is that? Bit of corrosion there. Green means there's oxidization going on. So there's something going on in this. I wonder if it's been stored damp somewhere. Anyway, so an EZ81. We can test that on my tester, which will be the next video. But that's one valve. So this one here, marked V6, is a 12AU7, also known as an ECC82. And again, this one is marked Heathkit, and it says a Schlumberger company, 12AU7, made in GDR. Now, off the top of my head, I couldn't tell you what GDR is. Probably Russia or the Soviet Union, somewhere like that. I don't know. I will check. It doesn't really matter. But yeah, Heathkit branded as well. 12AU7. Looks great, doesn't it? So one side. ECF80. Now, actually, I've got a lot of these as spares. I bought a job lot of valves on eBay once, lots of old radio TV valves, and I've got maybe 10 or 12 ECF80s in boxes, so I know I've got good replacement for that. See, that one doesn't say made in GDR, which is interesting. Don't know what that code means. Probably a production code. Look at that. ECF80. Right, there's one over here, which I believe is an ECC83, also known as a 12AX7. Heathkit, foreign made. Now, when I bought this scope, I was secretly hoping that this would be a Mullard or a Brymer. It might be, I don't know. But it's probably a Russian valve. The Chinese weren't making valves back in this date. Oh, look at the corrosion. Look at the oxidation there. I wonder how that would sound in a guitar amp. I don't know. It's not a long plate, but it looks fairly well constructed. Nice and strong. Big getter up there. Big halo. Sorry. Interesting. Right. There. Let's tell you what, while we're just on this side, let's have a look inside. So we've got a cap there for trimmers or transformers. That they look like IF transformers and radio coils, but they obviously do something else in this. Big 2-watt resistor there and there. I guess they'd need to be matched. And there's a cap inside in between that might not be able to show you on camera, but it looks like it's got a big bulge in it. So we need to check that out. The two filter caps. This is a 50+50, and this is a 40-40-20. Gonna think of a way with how to replace these. They might be good. They might be good, but I mean, we'll certainly test them. But they might be good. Right, let's spin this around. Take a look at the other side. So we've got here another 12AU7 in V1. And this one doesn't say made in GDR. It doesn't look like it's been rubbed off either. So I wonder if it's just a mix and match. Let's get the other one. The one that does. The construction certainly looks the same. Interesting. Okay, sorry, let's go back to this. So we've got another 12AU7 here. Come on, here you come. and another one here. So 4 12AU7s or ACC 82s. Sorry, I'm actually looking at this through the camera as well rather than with my eyes. It doesn't look right, does it? Oh, actually, maybe it does. Maybe it does. Maybe it's just a piece of dirt there. There you go, another 12AU7. So I've got some valves to test. Tell you what, while we're here. More resistors, more caps. Look at the tropical fish there. Cap there. This is the front of the scope. This is the rear of the scope. Big mains transformer. Custom Transformers Limited. Malm, somewhere in Wiltshire. And here is the underside. So we start at the top. So these are the two filter caps, and that will be the rectifier socket. Yeah, there you go, cathode connected straight there. We'll have to test all of these. Going down through. Quite clean under this side actually. And some caps left. Now, what I found is from experience is whenever you've got lots of dust on a certain component or wire, you know that's a high voltage section. Well, there's high voltage there. Some Erie or Erie caps. And in the bottom, here's the input sockets. A couple of pots. Now, if you ever buy a Heathkit piece of equipment, they were kits. So you would choose what the piece of equipment you wanted. You sent off for it, and it came in a kit, and you had to assemble it. Now, most of the time, it wasn't professional repairmen who built them. It's usually the home hobbyist. Not all the time, of course. There's always an exception. But they were usually built at home, and what happens is you get, people want to get their kits built quickly and working, and they want to test things, and so sometimes you might miss a solder joint, or you might not do it properly. So if you ever have a Heathkit or anything by Heathkit, really pay attention. Make sure all of the solder joints are where they should be. I haven't seen anything unsoldered yet, but you never know. You never know. So there we go, the Heathkit scope. So what I'm going to do with this video is I'm going to restore the scope, get it working. Now, this is not a how-to. This is not a follow my steps and everything will be okay. This is simply me documenting the restoration of this scope. If you decide to work on electrical equipment, you do so at your own risk. There is very high voltage in here. It wouldn't surprise me that on the back of the scope here, or on the brilliance controls on the front, there's close to 1,000 volts, maybe even more. The highest capacitor in the circuit is rated for 1,500 volts. So that's extremely high voltage, and it does hurt, possibly even can kill. So please, at your own risk, and take lots of precautions. So thanks for watching this video. In the next video, I will be testing the 3, 4, 5, 6, 7 miniature valves. There they are. I haven't got a CRT tester, so I can't test the CRT. But I'm confident that once we've done the restoration, we should be able to get something. Okay, thanks for watching.